Hey everyone, and welcome back to this new episode of the Orkestra YouTube channel. It is episode 3, and in this one we're going to be generating 3D geometry for Revit rooms. This is something that's unfortunately unavailable in out-of-the-box Revit, and this is sort of a workaround to get those rooms to be visible in 3D. It can be very useful in many visualization scenarios. So this is what we're going to be doing. Our goals in this episode are going to be pretty similar to those of the previous one. So we're going to be building an actual reusable tool with OkPy. So something that you could use in your everyday real project work, and also something that you could deploy within your firm. And while doing so, we're going to be learning about the Revit API, how to browse it, how to use it, how to understand it. Learn some Python as well, though this is not really a Python lesson. I'm pretty sure there's some elements to pick up here and there in terms of like understanding the syntax and the way it just generally works. And I'm going to also be sharing some tips and tricks that I use in my personal development work. Our steps for today's tool are to get all placed rooms. So that's going to be our starting point. Then we're going to need to create that 3D geometry using something called direct shape. Direct shapes are a class in the Revit API that allow us to have some geometry that carries data in our models. More on that later. And then the final step is going to be injecting parameter values from the original room elements to this 3D geometry that we'll be generating, because those are going to be two separate elements. There's no way to actually get those rooms to show in 3D. So we're going to be building geometry that sort of mimics the geometry of the rooms in 3D. And we're going to be injecting parameter values, which will pave the way to many use cases. One of them is going to be covered in episode 4. So yeah, let's do this and then stay tuned for what's to come next. All right. Again, I'm going to be using Revit 2023 for this video and Orkestra 1.6.1. And I'm going to create a new tool. For those who haven't watched the first video, please do so because it's going to help you understand how OkPy works. So I'm starting a new OkPy tool with the Revit template. I get my imports and my variables that are useful, and I'm going to start with some comments here documenting the steps that we're going to be going through. So we need to get all the placed rooms in the model as we just saw together, then create that 3D geometry for each one of the rooms, and finally the injecting data from the rooms to the 3D geometry. So those are the only 3 steps. So this video is going to be a little shorter than the previous ones. First step is to get all the rooms. So I'm going to be using the filtered elements collector, which you should be familiar with by now because this comes so often. It's a classic. All right. I'm going to use the off category filter on the filtered elements collector because the off class the room class is a little weird. It's actually called spatial element, and it's the same as spaces and zones. So I'm just going to go with categories and browse the built-in categories in api-docs.co. And the category for rooms is very straightforward. It's ost.rooms. And that's it. So there are no types for room elements, so I won't need the where elements is not element type in here. I'm just going to go right ahead and perform a little list comprehension to get the actually placed rooms, because in this all rooms list, I might have some rooms that are actually not placed. And those might mess up our code and logic. So for room in room for room in all rooms, if room.area, the area is a parameter of the rooms, it's an attribute. If area is superior to 0. That's a very easy and straightforward way to make sure that we're only picking the rooms that actually are placed in the model. I'm going to use a print statement in here to make sure that we are getting what we're expecting to get. All right, and in the console, I can see that I have a list of Autodesk Revit DB architecture.room objects. So that's perfect. We can move to our next step. We need to create the 3D geometry for each room. Now, as mentioned during the little intro, we're going to be creating some direct shapes. So we need to iterate through the all placed rooms list. So for placed room and all placed rooms, we're going to get the geometry of the room. This is something that's, I'd say, rather generic. All the elements in Revit have this method. It's called get geometry. So I'm creating a geom variable equals room, place room. That's the name of my iterator dot get underscore geometry. And this method here, if we look at the API, and I'm just going to look for the element class, which is the base class that everything inherits from in Revit. So the element class has a geometry, get geometry, and this is going to return a list, or actually a geometry element called, but it expects an argument called options. And this options class has a constructor. It's very simple. And this is a class that we can use to specify the detail level, the view that we'd like to query the geometry from, these types of things. And here we're going to be very generic and keep it just like options, open and close parentheses. This will construct an instance of these options. We're not going to specify anything more. This is actually going to return a Revit, a .NET list, or a Revit API class that inherits from .NET list. So we're going to cast it into a Python list just for our future use. And we're going to get the first item only. That's what the 0 between brackets is here for. We only want to get the first element of that list, and this is going to be the solid. Now that we have our solid, we're going to create the direct shape element. So that's the class that I told you about during the introduction. And if we look at the way it's described in the Revit API, they say it is a class used for externally created geometric shapes. And this is a way for us to generate a rather light and clean geometry in Revit. And the most interesting thing also is that it carries data. So it is very useful because we can then use it and use filters on it because it carries data. And it has a bunch of constructors. The most simple one here is the create element. So that's what we're going to use. It only asks for the current document and the category ID. So we're going to use that constructor. I'm going to call it direct shape equals direct shape with capitals exactly as it is called in the Revit API dot create element. We're going to use the conveniently already available doc variable. That's the current Revit document. And then we need the category. So for this exercise, I like to use the generic model category. You can use any category you want, or not any really, because you will be able to create a geometry in the room category. Those are, categories that are not sort of allowed for you to work in. I've tried other categories that didn't give me any success, and I just sort of decided to go with the generic model category because it was the simplest and it always works. Maybe somewhere there's a comprehensive list of the categories that won't let you create direct shapes. Okay, so I'm just going to use this element ID constructor and give it the built-in category OSD generic model. That's how it's called in the Revit API. And so far we've created the direct shape element, but we haven't specified any geometric information for it, right? So if we look in the API, it has a method called setShape. And this setShape method is, well, there's actually a couple named the same. These are what we call overloads. So it's many definitions called the same way, but that have different arguments and do different things, but the same outcome basically. So let's use the setShape. That actually is going to take our room solid, and we're going to put this in between brackets because it wants a list. So it will be simpler this way. All right, now we need to name this shape in order to find them easily for cleanup. And what I mean by this is we want to generate geometry that we're able to delete every time we rerun the tool, because we want a tool that's able to clean up after itself and update. So that's why we're going to set the name of our geometries to 3D room. And before we go any further, I'm actually going to create the cleanup transaction here. So cleanup the previously generated 3D room geometry to update at each run. You know how walls may move in the project and room geometry may change. So what we want is every time we run this tool, it deletes all the previous 3D geometry that we've generated, and it creates new geometry that's up to date with all the modifications that have been made in the project. So as usual, I'd say now we're going to create a cleanup transaction. That transaction is going to be running in the current document. Let's name it as we start it, just so we can visualize in the undo redo tab what's going on. And we're going to be getting all the geometry to clean up. For that, we're going to use the filtered element collector. Again, a classic. We're going to use that collector on the current document that's stored in the doc variable. And we're going to use the direct shape class. This will make things easy for us, because the geometry that we've generated is of the direct shape class. Let's just rename this DS direct shape, because this is going to be the list of all direct shapes, and then we need to filter those direct shapes to only those that are the ones we've generated with this tool, because we may have other direct shape elements in the project. So for D in DS, if DS and not def, autocomplete's a little rough here. D name equal 3D room. And that's why I wanted to name my 3D rooms as we were creating them. This is going to make things easier for us to identify. And then I can iterate through this list. So for geometry and geometry to clean up, and then we use the doc.delete method that expects the element IDs. So geometry.id, and we can close our transaction. So I always like to make tools that can clean up after themselves for many reasons, really. And I'd say like the most important one is that your users are not necessarily going to think about all these things, that they need to go and delete the geometry before they rerun the tool, and it's going to end up being a mess in the project. But if the tool runs the cleanup itself, then you're going to keep your model clean, keep your users happy, and it's all going to be better. All right, now we need to inject that data from room to 3D geometry. And for that, we need to let the users pick which parameter we're going to be using. I'm going to build an input, a drop-down input, all right, let's customize this dummy drop-down input. Let's rename it room parameter to inject. because yeah, this is what we want to inject. We give it a little description for users to make more sense of it. This the value of this parameter will be passed to the 3D room geometry. So we want the users to pick any parameter from the rooms and then pass it to the 3D room geometry that we generate. So let's reference the Revit API. Let's import the modules that we're going to need from Autodesk, Revit DB import. We're not going to use the wildcard imports. We want to be more selective. So import the filtered element collector. Has FEC, makes it faster to type. Now, we are going to do something that I often do when I want to get the list of parameters for the room category. I think there's probably, there's definitely other ways. I don't know if they're better, but they're out there. So I get all the rooms with the filtered element collector. Does the built-in category take an S or not? I used it earlier. Yeah, there's an S. Okay. So OSC rooms. Forgot the parenthesis here. All right, of category. So querying the list of all rooms and then turning it into a list of elements and then picking the first one with this 0. So I'm using this tool so I know there's at least one room in the project. And this should definitely, help. So I need the room parameters. I want the list of all the parameters for the rooms. I'm going to build this dictionary. This is what I'm going to be returning. And I want to iterate through all the parameters. So for parameter in first room, that's the first room we got, dot parameters. Because in the Revit API, every element, so again, we're back to the basis of pretty much every element in Revit. They all inherit from this class. And the element class has a parameters property that contains the list of all parameters that it carries. So the parameter set is a list of parameter objects. And if we look at the parameter class, there's a little specificity here. I'm going to save you some headache. If you look for the name of parameters, you're going to need the definition of the parameter first. This returns the object that describes the data type, name, and other detail of the parameter. So this is something that we'll need to go through. We are going to add a key to this room parameter dictionary. And we're going to get the definition, then the name of the parameter that we're iterating through right now. And we're going to assign the name of the parameter. That should make things easier. So that's it. That's the dictionary we need. We're going to use our out dictionary. This is the dictionary that is used to return values for the dropdown. Not happy. Module. Right, forgot an E, have a typo. Okay. Yeah, built-in category as well. Still not? Right. Forgot the documents. That's a big mistake. Still not. Doc is not defined. Right. Well, yeah, we need to store the built-in current document, so current doc with underscores before and after. All right, much better. We're still getting the initial ABCD list. Right, okay. Yeah, this is again a mistake that I made. The output dictionary that OkPy picks up is not outdict, it's just out. with underscores before and after it. Okay, now we're good. This is a list of all the room parameters. So I made a couple of mistakes here. I don't think I'll edit them out. I generally think it's good to see the mistakes and to learn from them. So I think I'll keep this in the video. Let's keep going. Next step is to get the parameter value for the room that we're iterating through. So let's say we go with the name, because in this model, name it makes sense. So the room name equals the placed room, the iterator. So this is the current room that we're looking at as we're iterating through the list, and we're going to use the lookup parameter method to fetch the parameter value based on its name. This is equivalent to the get parameter value by name in Dynamo. Just going to first get the value that's selected in the UI. So room parameter to query, and let's rename it. Let's give it a key. Again, for those who haven't watched the first episode, this is where we explain all of this stuff. So I'm going to use the built-in inputs dictionary and use this room parameter key to get the value of this parameter. All right. So yeah, let's say a room parameter value instead of room name, because we could pick anything really. Room name was a little too directed. So we are going to look up this parameter, and we're going to use AskStream here to get its value. Now, yeah, I think if you want to make this very, very robust, we should handle many scenarios where the parameter is a string or an integer or an element ID. So parameters can have different natures. Here, let's just stay with string and string parameters. Yeah. So we're going to just use a little doc.regenerate here to make sure that the direct shape that we've created before is actually really in the document. Because the next thing is we're going to inject the parameter value that we've just queried from the room into the direct shape that we've created. So we use the same logic to get the parameter. Direct shape.lookup parameter, and then we need a parameter name. So we're going to use the exact same logic. I'm actually going to copy paste the code that I had in this input and create another drop-down input. I'm going to use the out-of-the-box base, paste this, and the only thing I need to change here is the name of the category. And I used this before, I know it's generic model. Let's rename the input parameter to set on room geometry, room geometries. This value will be stored, or this parameter value from the room or the selected room parameter will be stored in this parameter. If this makes any sense. Okay, so now we have a place to pick. Wait a second, I don't see the comments because that's what I wanted to use. Okay, yeah. I'm going to add the where element is not element type filter here, because I think it picked up like the first element it got, and that's what's dangerous with this first element strategy, is that it may pick a type or an unplaced room, but that's no biggie for parameter names because unplaced rooms will have the same parameters. Yeah, perfect. Now that we're only looking at instances, we get the comments, so we're good. So GM parameter, generic model parameter. We're going to use this key to store the parameter name in the GM parameter variable, and we're going to use it here. So, okay, now we're looking up this parameter for the direct shapes that are generated. and we are setting the value using the one that we got a couple of lines above. So the room param value. And now we're passing this value from the name of the room or whatever parameter we pick here. But for our example, it's going to be the name. And we're writing it in the comments of the directory. Now let's go back to the sheet that we've generated in the previous episode, where we can visualize all of this happening live. All right. So we have our exploded axonometrics here. One thing that I usually advise to do for this tool is to generate the 3D geometry in a dedicated work set. And this dedicated work set is to be turned off by default, because this 3D geometry that we'll be generating is something that we only want to see in selected views. By default, we want it to be hidden. Otherwise, it will interfere with a lot of your graphics display. So this is really the way to go. I usually put a hashtag in front of these type of dedicated workspaces. Makes them easier to locate. And we make it not visible in all views by default. Yeah, let's make it the active work set. Now let's apply a template to all of these views. The same view template. Let's use this one. We're going to use the template to make sure that the work set, the 3D room dedicated work set is visible. So by default, it's not visible, but yeah, just seizing the opportunity here to make things look a little better. And then work sets, all right. So we're going to show them in this template, this specific template. So, so far there's nothing to show. This is just going to apply the changes that I just made to the template. All right. Looks good. Okay. Back to our tool. We are going to run it. Okay, there's a mistake. Solid is not defined. That's all right, because it's room solid. Okay, forgot an O. Let's fix this. Awesome. All right, that wasn't too bad. Only one mistake. Okay, now so all of this gray stuff that we can see here is the 3D room geometry. And see here in the comments, well, those are the names of the rooms that were used to generate the 3D geometry. So that is exactly what I was expecting to see. And this is really great because it opens the door to so many workflows and use cases. One of them we will cover in the episode 4. So let's add a little description to this tool. That's name, room, volumes. Let's save it. And let's add it to our ribbon the same way we did the previous one. So episode 3 in Orkestra, add to ribbon. All right, here it is. And one thing that I would like to show you here is this ability that I was talking about earlier, that the tool has to clean after itself and update instead of just generating geometry on top of geometry. So let's say we move this wall, right? As you can see, the 3D geometry has not adapted, and well, this is normal. What I'm going to do is launch the tool, and we can see here that we have it under the user mode, no editor. Pick the parameters, we hit run. It doesn't take too long. That's the cool thing with OkPy. It's super fast. And also direct shapes, they're pretty cool. And as you can see, they have updated and adapted to the new room geometry. Okay, so that's it for today. This episode 3, on top of episode 2, is paving the way to episode 4, where we'll be wrapping all of this up and building a really cool use case for this 3D geometry in the exploded axonometric views. So really stay tuned. I think you're going to like the next one. Don't forget that if anything comes up while you're trying to reproduce all of this, or if you try and use the tools and they don't work, you can reach out through the forum. That's forum.orkestra.online or through our website. I'll also put the tool for download in the comments of this video, and I hope to see you in the next video. If you like these videos, subscribe to the channel. You'll be posted every time something new comes out.